I would like to introduce Rodrigo, who is our moderator. Rodrigo Ribera is the author of Urban Politics, The Political Culture of Sur 13 Gangs, and the writer-director of the award-winning documentary Dark Progressivism, an urban studies film that follows the trajectory and impact of Los Angeles gang graffiti, murals, and tattoo art. He holds an MFA in creative writing, and his work has been featured in the Los Angeles Review of Books, Design LA Magazine, Juxtapoz, Joyland, the Huffington Post, and other publications. His forthcoming novel, The Displaced, is scheduled for publication this summer from the University of Houston and will be the book for our book club in August. Dear Rodrigo, I will pass it on to you to introduce our three panelists, and let's get started. Yeah. Thank you.
Thank you, Eva. Thank you. And once again, thank you to California Humanities for providing this grant to us for the Futurisms of Symposium. So, I want to introduce Dr. Mark Knight. Dr. Mark Knight is a research scientist, and he's also a photographer, a filmmaker. Recently, he just directed and produced and edited Being Black in Mayberry, which was sponsored by the Segunda Museum of Art. So if you haven't seen that documentary, beautifully shot, take a look. Next, I want to introduce Breja Johnson. Currently serves as a technology scouting manager at UCLA Technology Development Group. She supports an early stage aerospace and defense accelerator called Scale, run by Starburst Aerospace, that helps entrepreneurs expand in the industry. This fall, they are hosting a Care in Space program centered around space health and prolonged human activity in space. And Shauna Mabari, she's a Los Angeles-based American contemporary artist focusing on the intersections of art and science. Her collaborators include experts in the vision sciences at the California Institute of Technology and in the neurosciences at Zurich's Institute of Neuroinformatics. In 2018, Mabari was selected to be the first artist to fly aboard a mission of NASA's Stratospheric Observatory for Infrared Astronomy, also known as SOFIA. So, thank you. Okay, let's get started. Global exploration has led humanity to space exploration, but can humanity really extend beyond Earth? Does anybody want to answer that?
So I can jump in here. I think there are a lot of questions that are still being explored around sustained human activity in Earth. We have a lot of missions that are more recently exploring opportunities like what planets are beyond Earth's atmosphere, how are we going to sustain food supply or medical resources as we dive deeper into space. So I think that we can get there, and there are innovations being developed for longer term exploration and study of these other planets. But we are still in the early phases of that. I don't think we're quite at the place where we can have long-term, warm, voluminous populations on these other planets.
Yeah, I wanted to talk a little bit about what beyond Earth means. Because when we say other planets, I think we've all grown up with the concept there's a lot of planets out there. We have a solar system. That solar system exists within a galaxy. That galaxy is one of many galaxies that exists in the broader universe. But it's very hard to sometimes understand the sense of scale involved because none of us have ever traveled over that type of scale. And conveniently, there's a thing we have traveled over, and that's time. We've all traveled through, I'm looking around the room, at least a year of time. So in physics, we frequently convert distances into time, and the reason we can do that is the speed of light is a constant throughout the universe. It travels at 186,282 approximately miles per second, which is very fast but very finite. And so you can convert distances into time by just doing a simple multiplication. So if you wanted to go from here to downtown Los Angeles, that would be 8 times 10 to the minus 5 seconds, or 80 microseconds. For reference, that's multiple orders of magnitude faster than a blink. And so you're incapable of perceiving it. So it appears that downtown Los Angeles is now as it actually is. However, if you wanted to go around the Earth, which Jules Verne described doing in 80 days, if you were a light particle, you could do it in 0.13 seconds. To get to the moon takes 1.3 seconds. Longer, you can start to measure that, right? To get to the sun is 8.3 minutes, which is actually a fair amount of time. And that also means when you look up, the sun is actually fairly old at that point. You're seeing 8-minute-old light. When we talk about going to other planets, Mars is the one that's probably going to come up a lot today. Mars is, depending on where it is in the orbit around the sun, between 4 and 24 minutes away. And yet, Mars is very close. When we talk about later, is there life out there? We're talking about vast distances. The closest star is 4.3 light years away from us. And so the distances and the scales involved are going to be vast. And so when we say beyond Earth, there's a lot of beyond Earth.
I would say when we talk about beyond Earth, I would say yes, it's possible, but we're also talking about a very short distance. It's 62 miles or 100 kilometers from the Earth's surface is technically outside of the Earth's atmosphere. So that's our outer space, which is comparable to from El Segundo to Monterey, or from El Segundo to Kingsman, Arizona, or Baja, California. So it's an extremely short distance that we're all just overly, excited about and obsessed with at the same time. Those distances, I think, bring into account just the reality of what happens between us and outside our atmosphere, and then there's just the distances and the numbers that Mark was talking about.
Right.
So it's possible. It's just a matter of getting through the break, so to speak, to out in outer oceans.
So when we talk about beyond Earth, this is the complexity of what we're talking about.
Absolutely.
Great. Okay, so is there life beyond Earth?
I think this is one of those topics where we still have a great unknown, but there are a few missions that are looking to explore this on different planets. So if we look at, for instance, the Mars 2020 mission, that was looking to explore ancient life on the planet through collection of rock samples, broken pieces of soil and rock, and studying those to determine if there was sustainable life on this planet at any time. We have proposed missions like the ELF mission that will look at Saturn's moon to study astrobiology there and determine if there's a possibility for development of life in that atmosphere. And then we have a more closely aligned upcoming mission to Europa Clipper, which is the Jupiter's moon, and looking to explore sustainable life and the conditions there for development of a life form. So I think this is still an area that's being explored, and I know Mark has some insights on the two theories that are looking to tackle this and the probability of there being life, deeper in the universe.
Before you answer that, can you tell us a little bit more about this ELF project? I haven't heard about this, so can you?
Yeah,
this stand for?
Yeah, this is looking to explore Saturn's moon and taking images and collecting samples from that surface to explore if we can take, for instance, I know there have been studies or research looking into the tardigrade, the indestructible worm, and looking to send that into space to see if they can stand a certain level of pressure or radiation and multiply in this environment. So I know that there are different methods and missions looking to tackle this question more concretely.
Mark, did you want to add to, is there life beyond Earth? Is there some research that you've done also?
Well, unfortunately, it's not my personal research, but it's from within the broader community. This is actually fairly old at this point, but there's an equation called the Drake equation that doesn't answer the question. I'll preface it with that. But it does provide us with a framework by which we can think about that question. Just, can I get a quick show of hands? Who in the room has heard of SETI? Search for Extraterrestrial Intelligence. Fascinating, it's this side.
They're all over there.
All right, everybody on my right has heard of SETI. Great. So if you think about what that's doing, SETI is using radio telescopes to look for structured transmissions coming from outside of our solar system. And to have a structured transmission, you're looking for a specific type of life, a very intelligent form of life that has decided to broadcast large amounts of power outside of their own planet, right? So to do that, you need a technologically advanced civilization. And what the Drake equation does is it provides the terms that let you probabilistically understand how many technologically advanced civilizations there might be. That includes the rate of star formation in the galaxy. And why the galaxy? Well, it's really hard to get things from outside the galaxy. The galaxy is already very, very big. So we'll look at the galaxy. All right, how many stars do you have? How many of those stars have planets? You can't live on a star. You need a piece of rock to sit on. So how many pieces of rock have we got that one could plausibly sit on? How many of those rocks exist per star? You know, we have 8 or 9. If you want to count some of the asteroids, we've got more than that. How many of those planets could life appear on? Right now we think that life needs to occur in a Goldilocks zone. Breja might talk more about that. But you need to have liquid water, or at least something that's not going to destroy organics. Of the planets that could have life, which ones get life? Of those that get life, how many go from things like tardigrades all the way up to something like us? And of those, how many then start releasing large amounts of radiation that SETI might actually detect? And what you'll notice is all of these are massively large numbers or massively small numbers. And you're multiplying all of them together, so there's a tremendous amount of uncertainty. However, that number that it predicts is not 0. And that's the interesting part. It tends to produce numbers with massive margins of error on the order of thousands.
I think as far as life beyond Earth, there I would agree, yes. It's a matter of finding it or them finding us. I think the moons of Jupiter are probably one of our most interesting observations as far as having, ice on the surface, perhaps water underneath those ice areas. But with the amount of planets and the amount of space, I think the organisms, whether we're talking about life and the definition of life, or talking about organisms or cells or complex organisms like ourselves. So it's a matter of time, and with now the James Webb being launched and having more information coming through, I think the next 50 years are going to be much more fruitful than our past 50 years that have been incredibly fruitful. So we're at a very fortuitous time to be on the planet, and especially in El Segundo, and having sister cities of Palmdale and Lancaster and all of the research that's happening right here.
If you don't mind, I want to tack on just a little bit about James Webb. Remember how I said that distance can be communicated in terms of time? Well, if you look at the photons we're receiving right now, you can rephrase that and say that the older the photons are, the more distance that they've covered. Or, put another way, the further back in time they come from. So photons coming from remote pieces of the galaxy are, in a very real sense, sharing with us different pieces of the time in the evolution of the galaxy. So if you want to know what happened when planets were first forming or stars were first forming, or the conditions for life might have first evolved, you can't see that on Earth now because all that's past. But you can see it if you stare into space.
Okay. Thank you. All right. So first we have cruises, then flights to far-off destinations. Soon, the premier holiday experience may very well be a rocket ride to space. What is space tourism? Can we talk a little bit about that?
Yeah, I can kick that off. So when I think about space tourism, I'm thinking about moving things from science fiction to reality. So creating experiences for astronauts or the common citizen to explore space for recreational use, leisure, or even business purposes, like working in space to sustain the environment there. I've seen companies who are looking to develop, for instance, a hotel in space or office space stations. Orbital Assembly is trying to tackle this concept. So we also have other companies like OrbitFab, who is dealing with gas stations in space, and they've recently raised a $12 million round between public and private investment to support military satellites and using their tankers to fuel their satellites as propellant. So that's what comes to mind when I think about space tourism.
So this hotel, is it halfway between a distance somewhere? Like what are we talking about a space hotel? This is a little difficult for me to grasp.
Hotels.com.
Right, yeah. So the depictions I've seen is sort of this circular station that has these different pods where you can have entertainment or host office space or go to the movies, for instance. Like people are thinking about these concepts now and that have viewpoints where you can utilize your environment and looking out into space and down onto Earth, but still functioning as if, as today, we could be hosting a talk on this new hotel in space.
So cheaptickets.com, you can find the space hotel. Okay.
Frisia has your discount ticket.
Okay. So who is funding these endeavors?
If I could just speak about space tourism just
Sure.
for a moment.
Yeah.
What's so fascinating is that the industries are, we have, 4 at the moment that I was able to find. We have Virgin Galactic, Richard Branson's, we have Blue Origin, Jeff Bezos, SpaceX, Elon Musk, and as well the Russian Space Agency is hosting our space tourism. As far as space industry goes, or the people that are bringing payloads to the ISS, those are now Elon Musk, NASA, and the Russian and Chinese space agencies. But the industry is probably comparable to what we saw with air flight, in the 30s, where we thought there is no way that people are going to be doing this. It's it's completely far off, and next thing you know, we're all flying everywhere. So it'll be interesting to see again how that comes up to household conversations.
Who gets to go?
I'm glad you asked. So there was recently a market study done that looked at what happens as this industry matures and becomes more like a standard air flight industry. And first of all, none of us are probably going, because it's always going to be something for high net worth individuals simply due to the amount of propellant involved. One of the things that dictates the price of jetliner flights is how much gas it burns to get you from A to B. On a rocket, you're fighting against gravity for a substantially lot longer trip, and so it's going to be expensive. That said, there's approximately 2 million people who have that amount of money and have expressed an interest in going. So there's a market study that says that by 2030, this might be somewhere around a $3 billion market to just send people up to have fun. I think there's a couple different classes of tourism that you're going to see as well. There's the 4 tourism providers that Shauna mentioned, along with, interestingly, Boeing, which has permission to sell the 5th seat on government missions. So you might see some side-alongs there. But those tourism providers are going to do a couple things. They're going to do the suborbital things. And suborbital means you basically shoot up in the sky and you come back down. It's basically the human equivalent of a firework, right? They don't stay up there very long. And so you're looking at a few minutes of weightlessness, and that few minutes is really just you on a parabolic trajectory where you're under all of the same forces of gravity that you normally are, but you just don't notice, right? So that's parabolic trajectories in suborbital. You also have single vehicle orbital, where you'll go up in, say, a Crew Dragon capsule through SpaceX, and you've seen this happen already, and you'll do a couple trips around the Earth, you'll look out the window, and then you'll deorbit, no problem. Then things get more interesting, and what we're talking about with the space hotels are the orbital rendezvous flights. That's substantially more complicated because you have to already have a hotel in orbit. And that's already been taking place through Roscosmos for years now, where rich people could pay them to get launched on a Soyuz and then dock with the International Space Station, which is one of the original space hotels. And then things get really exciting. If you go to Hawaii, you might want to go scuba diving, right? And now space passengers think, well, maybe I want to go on a spacewalk. So that's sort of the space equivalent of scuba diving. So I think you're going to see the add-ons that increase the value of the trip.
Do you know if there are any efforts to make this a little bit more democratic? Or, just as opposed to just high worth individuals? Is there going to be like a lottery system where maybe other people are going to be allowed to go?
Sure, and interestingly, that's already happening. You've seen some of the high net worth individuals actually want to have interesting people with them, and not all rich people are interesting. Sorry. But they've been taking along artists, actually, in some cases, because if you really want to understand what was it that you saw when you were floating and looking out the window, the artist might help you frame it in a way that gives you better insight.
Well, one person who is very interesting, Guy Laliberté, the founder of Cirque du Soleil, was up in space. He paid $35 million to the Russians to be able to do that.
So I'm looking forward to that Cirque du Soleil show. Sounds awesome.
It'll be good.
It's called Space? Silly? No, I'm just joking. Right. So who is funding these endeavors?
So I think initially, largely these efforts were siloed to government, more established corporates, but now we're seeing more commercial opportunity here. So it's opening up, just from my perspective, I'm seeing a lot more private investment going into funding early stage companies looking to explore this more deeply. So I think initially we had it from government funding or early research plans, from things like the small business innovation research grants, so SBIR grants, SDR grants, funding this early exploration tours. But now with SpaceX and all these other commercial actors opening the market, I think we'll have more private investment in the industry.
Okay. What are some of the benefits or detriments of space tourism?
I think space tourism is going to be very, very beneficial for the appreciation of our home planet. Being able to get a distant view of the preciousness of the Earth, the limited amount of land on the Earth, the very thin and fragile atmosphere that keeps us alive and away from very harsh conditions in space. So I have, I'm betting that space travel is going to allow a higher appreciation for the home planet. I hope I'm right.
There's going to be good and bad sides. I think one of the challenges, just like with cars, is a space vehicle is still a vehicle, and you're still using the rocket equivalent of gas. The difference being you're injecting a lot of the exhaust from burning those fuels directly into the upper atmosphere where they have the most impact on greenhouse warming. And there have just started to be studies on the impact of rocket flight and launch vehicles on global warming, and it's not a big contribution right now. We've got a lot more cars in LA than we have rockets going up every day. But as that balance shifts, it will become more of a problem. So I think we'll have to start really considering the environmental impacts, which you're starting to see with alternative propellants. People are starting to look at propellants that burn and produce water instead of greenhouse emissions.
So, Shauna, you talked about appreciation. So, have there been studies? Have we read articles about these people that are going up to space and coming back and saying, hey, you know what? I was able to see this from afar. Maybe we should put more resources into preventing climate change or other issues that we have on the planet? Is that being done?
From what I understand, there has been a few astronauts in the International Space Station, when they get a glimpse of Earth, talk about coming back down and really having a different relationship on the home planet, being far away. And it really happens with travel. If you travel to another country and you spend a lot of time and you come back, you just see your home culture in a very, very different way. How that's impacting a policy, that I do not know. But I would say public opinion, public approval, will definitely move in that direction as there's a larger body of people. And right now, if it's a very privileged community, being able to take those space flights versus scientists and astronauts that have a very, very, very busy schedule with a certain task, so to speak, when you're going to the space station. But I think as that population grows, then we'll know what those issues are and how they're being dealt with.
Okay, so I want to ask a little bit about your work here. I think this is a good time to maybe talk about your experiences in the Canary Islands and the work that you've been doing there in relation to coming back home and appreciating home a little bit better from being abroad, working on this other project that you have been telling me about.
So in 2016, I did a artist residency on NASA's Stratospheric Observatory for Infrared Astronomy, also known as SOFIA. It is a 747 completely gutted, and an infrared telescope was built in the interior body of the aircraft. Unbelievable as far as engineering, the science that they do. It flies out of Palmdale during the winter months because your evenings are longer. And I was on a flight, and it was just an incredible experience just to be able to see what this community of scientists do. It's a NASA program with the German Space Agency. From that, I spent a couple of years on my studio on the north side of Ibiza, Spain, in the Balearic Islands in Spain, and studied the night sky. And I did a series of drawings and some sculptures. So this is the work, some of my work that you can see on the screens, and an installation at the Museum of Art and History in Lancaster that showed some of the drawing series. And one thing that was very prominent with the experience was that when you're flying on the infrared telescope, you're navigating in a similar way, where you're going up about 45,000 feet above the precipitation of the air, so that the infrared telescope is able to have a stronger connection, or a clearer connection would be more accurate. And you're basically zigzagging through the sky depending upon what scientists are studying for that evening. And it gave me an appreciation to say Earth is part of space. We are moving very, very quickly around things that are moving very, very quickly, around other things that are moving very, very quickly. And it's very difficult to really keep that in mind when you're not in a certain area of expertise. And in a lot of other communities, like, well, I'll do space on Thursdays. Well, you can't really do space on Thursdays. You can't not do space ever. And the drawing series was really this opportunity to be able to map the night sky. I would set my alarm for 2 o'clock in the morning when the moon would set and the night sky and constellations were bright and above, and be able to follow those, do drawings, and also have a series where there were transparencies where I would follow a planet or a constellation from my space on Ibiza out into the night sky, and then reverse it and say, how would that planet look back at me? And being able to have more of a relationship where I'm not the center of it all, but we are part of a larger moving body. This here is a meteor. You can see on the screen. That's a sculpture series that I did with the space work, and those are a series of, they're about 7 inches to 12 inches in diameter, and they're made from acrylic. And acrylic is an incredible material that is used a lot in aerospace. And the work this here is Astral Challenger. This I want to talk about because it was commissioned with the City of Lancaster in 2016, and it honors the Space Shuttle Challenger that was lost in 1986. So there are 8 panels on the bottom. 7 represent the lives of the astronauts that were lost in that disaster, and then 1 is represents the families and community and friends that are still grieving to this day. So really having appreciation for the aerospace community, and even though it's a very science-driven community, it's a very personal community. So the projects that people are working on, you take these home, you are investing heavily in your education, in your community, putting your life on the line to be able to go to space, which is an incredibly, incredibly dangerous mission. This is part of the Stella series. We did a wall installation at the museum. We have some meteors up on the walls. So I wanted to make sure that they were placed around as you would have in space. There is no up, down, sideways, right and left, because it is all front and back and moving. So I wanted the installation to be able to have that feeling to it. This unfortunately closed because it closed a little bit early for COVID, but it was a really great opportunity. There's also a publication I did with the space work where I invited a number of individuals to write essays about the term space. And one thing that I found was having a background in the arts and working with the science community for about 2 decades at Caltech, neuroinformatics, NASA, and I've been very, people have been very, very generous in sharing their information with me, but I found that everybody utilizes the term space in a very different way. Whereas artists will talk about what did the space look like. Astronomers will use the term space differently. Everybody's very married to the way they utilize the term space. So it's a collection of essays about the term space that includes some of the work.
And thank you for giving us some insight into your work and your process. So we're going to move on a little bit in regards to, can human beings survive on another planet? This is a possibility.
So I think there are 4 major areas that we're still working through to get past the restriction around the amount of time we can be in space now. So food, behavioral, mental health, medical independence, and radiation exposure are all things that are still in consideration. So I'll just take one of those. If we take food, for example, you have to think about the volume, the amount of food you'll need, the nutrition in the food that you'll need over longer periods of time. People are looking at developing solutions through greenhouses where you can test on Earth through things like the biosphere that is in Arizona. You can test out and study Earth in those enclosed environments and get a sense of how can we replicate this on another planet. I was listening to a podcast earlier that was talking about astroagriculture and the further development of cellular meats, doing lab-grown meats, and seeing how that might have an impact on food supply and longevity in space. So I think there are still things to be explored there. For instance, right now, the cost to send cargo, any goods to be deployed to space is a $10,000 ticket for just a pound of whatever that good is. So if we're looking for an economical solution, I think we have some more innovating to do in that space.
Yeah, Mark, I'm really interested in your opinions on this kind of survival.
Well, Bridget set me up for this because she said $10,000 a pound. And I think you hear that and you think, well, $10,000 a pound today. That's going to come way down, right? Because everything comes way down. But there's a fundamental challenge here. It's called the classical rocket equation. And it's derived from momentum conservation. And what it says is basically, if you want to go up, something else has to go down, right? So the way you get things going down is you take your propellant and you burn it. And when you burn it, effectively what you're doing is you're throwing it out the back of your rocket really, really, really fast. Because momentum just depends on speed. So if you want to throw out the least possible amount of mass, you have to throw out that mass as fast as you can, okay? So modern engines use really high performance materials to generate this really high pressure combustion, and that shoots out this propellant. The problem is, we pretty much maxed out the materials that humanity has. We're pretty close to some of those limits, so to drive down that cost is very challenging within some of the limits of the physics that we're operating within. This is a hard problem. So that's one, that's the rocket equation. The second thing I wanted to bring up, just because I want to get you riled up here, is radiation, which is one of these other challenges that Bridget mentioned. Radiation is very bad for us. We get cancer from it and we die. And we do that in a relatively short period of time, given the amounts of radiation in space. Now, why don't we get that on Earth? Well, Earth is a giant magnet, and so we have these convenient fields that surround us and shield us from that harsh space environment that has ultraviolet, gamma rays, X-rays, protons, electrons. It's all stuff that blasts through your body and destroys you. And if you want to protect yourself from those things, you need mass, just lots and lots of mass. But at $10,000 a pound, you may not want to bring that mass from Earth. And that means mining. When you start trying to settle on a different planet, you're going to need to set up a mining facility and figure out how to use the mass from that planet to basically encapsulate yourself to do radiation shielding.
Well, okay.
Well, I would,
Yeah. Shauna, let's hear.
given the amount it takes, monetary amount it takes to bring anything to space, I think if we're sending humans to space for long periods of time, we definitely need to talk about and think about the psychological impact of being away from the home planet. You don't want to spend millions of dollars sending somebody to space, then all of a sudden they're depressed and things happen. So, what would the housing be? What would their community, how do you create a community? How do you create a visual environment that allows humans to feel safe and to have those psychological benefits to be able to continue to survive? If you're talking long-term, generational procreation, how do you create that family base outside of Earth? We were designed perfectly for our beautiful home planet, and if we want to replicate ourselves in another environment, then we need to think about the things that are essential to us that we take for granted here outside.
All right, that makes me think about something. When you travel abroad, right, sometimes people want to stay abroad. They don't want to come back home. So when we travel this way as well, right, into space, do some people want to stay? They no longer feel comfortable when they come back home?
I have thoughts. I think they're going to want to come back home. And the reason I say that is one of the most remote outposts that humanity has ever set up for sustained habitation is McMurdo Research Station. That's all the way down on the pole, and it is really brutal as a place to live. The temperature is the easiest thing to understand, and it gets up to about 46 degrees in the summer, and it gets to about minus 58 on a typical day in the winter. Minus 58 is cold, that's unpleasant. But remember, at least you have an atmosphere to breathe. That helps, you have water to drink. On Mars, not only do you not have an atmosphere and you don't have water, but the daily high is plus 70. Well, we're familiar with that in El Segundo, but the lows are minus 220. That is brutally cold. It's substantially worse than any place humans have ever lived. And I think people are going to look outside and think, I'm kind of tired of being locked up. I mean, we've all been locked up for a couple of years. You want to get out after that.
That's hence the hotels, the resorts. You stay in the resort.
Yeah.
You don't come out. Yeah. All right. So we've entered a new realm of corporate/government partnerships. An example, right? NASA and SpaceX and others. What are the benefits or issues of having corporate America help shape public policy in regards to space exploration?
Well, I can speak to some of the benefits. I think we'll see cheaper travel to space for like new technology testing and things like that. I think also having corporate influence has helped to drive the need for innovation and diversity in the market. And we're also seeing, things that we're developing, exploring, having huge advantages for earthly application. So I can see those as a benefit. And actually recently, there was announced the NASA Axiom partnership for the development of spacesuits and looking at that spacewalking that we were talking about earlier. So I think that's some of the benefits that can come out from, having involvement from corporate input in space exploration.
I think the partnerships are very fortunate to be able to have those, government and private industries working together. There's absolutely, no reason why that shouldn't just continue to grow. They're able to, also SpaceX is able to reuse their rockets, what we haven't really seen before. I was able to see a launch up in Vandenberg Air Force Base where, SpaceX is launching their payloads and doing a ballerina move in the sky and then bringing a rocket back down on their axe. It is just an unbelievable, it's unbelievable what they're doing. So I think it's fantastic. Now the downside, the other great side is that governments then can also create certain relationships to govern the rules that are happening as we're going to space. So it has to be a collective understanding of how people are moving forward, and which we'll talk about later. But then the downsides is what happens when our earthbound frontiers and borders and countries don't get along, and then we start to bring those arguments to outside the atmosphere that we've seen recently with the International Space Station.
Yeah, I think to make good policy, effective policy, you need to understand what exactly it is that you are regulating and making policy around, and that requires technical expertise. And to get that technical expertise, you need to actually be in the field, and the people in industry are the people in the field. So you need them in the room to help with those inputs. But at the end, everybody responds to incentives, right? And if you're in industry, the incentives are very different than if you're in public service. And in the best case, the public servants are trying to do what's going to be best for their constituents. The people in industry are trying to do what's best for the industry. And so that actually provides a diversity of opinion as you craft policy that hopefully will result in good policy, although your mileage may vary.
All right, that's a complicated one, but all right. Some will argue that humanity's curiosity leads them to the exploration and development of new worlds. However, historically, this curiosity has led to conquest. Jenny Holzer once said, the abuse of power comes as no surprise. In regards to space exploration, are there plans or policies being put into place to avoid our previous shortcomings? If there are none, what might they look like?
So we have the Outer Space Treaty that's in place sort of as a foundation, which establishes that no one nation can own space. Space is for peaceful exploration and use that's available to the global collective to benefit everyone. We also have mentioned in the treaty that there's a ban of military weapons or military activity that can take place in amongst celestial bodies. So we have some things in place initially to avoid some of the shortcomings and faults we've had in the past. But as we explore deeper and further, we're of course going to need more governance and regulation around these other opportunities that we're coming upon. I think one of the things that we need to take note of is as more and more commercial actors are entering the market, there is greater need for asset tracking and management and returning the objects that are no longer operational out of orbit back to where they were launched from. And we don't want to get to a point, I know there's a term called Kessler syndrome, where if you're overloading a certain area, then you might not have access for these other nations or players that want to launch assets into space. So that may be one area where we can improve upon some policy or plan around making sure that we're providing equitable access for all nations.
Have we had issues with other nations in regards to these treaties?
I know there are largely just the major players directing sort of the mission, reliance, and opportunity. I'm sure there has been some discrepancy there, but I know that there are more countries getting involved, like actually I've had a couple early stage companies out of Kenya looking to expand things further and establish their blueprint in space. One of the companies that I actually have personally invested in is from Japan, and they were working on the cell-based lab-grown meat component, but before getting to that space, they tested out space salt as a seasoning for some of the food that might be in space. So I think there has been some past, let's say, incongruencies, but I think having the space treaty here and these other agreements and directives that are coming out is looking to make sure we mitigate that risk and are maintaining international cooperation.
Yeah, the reason I bring it up is because I've recently been reading about how these treaties have actually created more conflicts with countries as a result of trying to mimic the same concept in space. So that's why I wanted to know if any of you have come across this, or these issues are becoming more strained with other countries, China being an example.
Oh, I think you're dealing with humans, and we're going to see how our behavior on Earth is going to be. Our behavior in space is going to be similar to our behavior on Earth. We have treaties based on what we've seen in the past, so that we don't bring that out to space, so to speak. But I also think exploration is a very nice synonym for conquering. We are moving into, we're looking to go to planets, huge resources, a lot of time, very dangerous. And are we going there because we're curious, or we're going to eventually want to control, I would imagine, or we're perhaps afraid that somebody is going to do that to us? Going back to the Drake equation and for me, so I don't know.
We're going to do it first. Go ahead, Mark.
Yeah, so Brisha had mentioned the Kessler equation, or the Kessler theory. This is from 1978, and I think it's a really interesting thing to just be aware of. Because in 1978, Kessler did some moderately complicated math and predicted that somewhere around 2020 or thereabouts, we were going to start having a problem with artificial space debris. He was absolutely right. The model has held up. It's been refined over the years. But the overall concept is very simple. You don't need math. If you take one object and you smack it into a second object at high speed, you get multiple objects. And you see this on the 405 after an accident, right? Chunks of car everywhere. Well, in space, those chunks of car would be traveling at orbital velocities, which is faster than a bullet. A bullet might be traveling 1,000 feet per second or something. Orbital things are traveling, orders of magnitude faster than that. And so they can do tremendous amounts of damage. And so each piece of debris can then go off and cause more collisions that cause more debris. And so you get this sort of roughly exponential looking buildup in debris. Well, if this happens in low Earth orbit, outside of the region where atmospheric drag is significant, that debris can last for hundreds of years or more before it naturally deorbits through atmospheric drag. And the problem is that space is a public good. It's in all of our interest to have access to space. That's how we get our weather forecasts. It's why the GPS on our phones works. It's why we have high crop yields, because we know where to put water and we know where to put fertilizer. Space is a public good. But irresponsible management of space assets could potentially shut down humanity's access to space by creating a permanent debris belt. And so this is where ethics become very important, and why Bree just said earlier, we need to make sure we bring things back down as carefully as we put them up.
Okay, so I want to open up the floor to some Q&A, some questions that the audience might have. But before that, I wanted to know if there's anything that you all want to add to conclude this conversation. Anything that we missed out? Anything that you want to add about your work or some of the research that you're doing?
So this morning I was thinking about one of my favorite artists, James Turrell. He's part of the Light and Space movement, and he has this unbelievable land art in the desert in Flagstaff, outside Flagstaff, Arizona, called Rodin Crater. And he purchased a crater and built a telescope inside, which he basically can walk through the body. It's not open to the public. But he is a pilot and an unbelievable individual, and one of my favorite quotes is from him. He says, "Science strives for answers, but art is happy with a good question."
So on that note, right? Questions from the audience? Oh, come on, don't be shy.
Well, spaceflight is very dangerous, and we talk about tourism and allowing people to fly. What's your opinion about letting people take that risk? Should we allow people to take a one-way trip to space?
That's a good question. I think that if we're further along in some of these issues that we were talking about around food supply or radiation exposure, even things like medical supplies and medical resources, you have to establish a certain level of independence, because if something goes wrong while you're out there, there's no hospital, there's no, resource to run to. So I think that as we get more technologies around solving some of these major issues, I'm fine to allow people to go. Would I want to stay personally? I think I agree with Mark. I'd want to come back to Earth.
I do have a follow-up on that one. And to me, this actually connects to your James Turrell reference, interestingly. So I did my academic work in part at Rice University in Houston, Texas. And James Turrell built a sky space outside of the music hall at Rice University, and so I'd frequently go and sit under the sky space and watch the colors change as the sun set. That sky space by Turrell is directly adjacent to the Rice University football stadium, where Kennedy gave his 1962 address about going to the moon. And in 1962, everybody quotes it as, "We go to the moon, not because it is easy, but because it is hard." People remember that one? It's wrong. That's not what he said. He said, "We choose to go to the moon in this decade and do the other things. Not because it is easy, but because it is hard. Because that goal will serve to organize and measure the best of our energies and skills. Because that is a challenge we are willing to accept, one that we are unwilling to postpone, one that we intend to win, and the other things too." He mentions the other things twice. So why did we spend all this time and energy to send a man to the moon? At that time, it was a man. We did it because, yeah, the moon's interesting, but because the other things, those were women's rights, and those were civil rights, and that was establishing democracy above communism. The other things were very, very important, but to do those things, we had to organize ourselves. We had to get everybody pulling for the same team, pull our scientists together, get our technologies in order, and be able to deal with the challenges. So, should one person be allowed to strap themselves to a moderately controlled bomb to save the rest of us? Well, maybe.
Thank you all for sharing your knowledge. It was wonderful. I have a few questions logistically about the Space Hotel. I'm fascinated by it. So, would there just be one launch spot to go there? Would everybody have to go to one particular launch spot to get there? How long, as far as distances go, where would a hotel like that be positioned? How long would it take to get there? Realistically, how much time, what would be a agreeable length of a trip? Is it a week? Is it 2 days? Is it longer than that? And I assume there will be no outdoor dining, or I mean everything would sort of be limited.
Al fresco.
Yeah. How, like you mentioned, what environment would they create that it is agreeable and comfortable and soothing? That what would the experience? How would the experience be enhanced?
So this is actually two completely separate questions. One of your
Sorry.
questions is orbital dynamics. I'll take that part. The second part is you guys. Well, I'll talk about orbital dynamics. So the Earth is spinning, and we're spinning very, very fast, right? In fact, we go all the way around on a pretty regular basis. So it turns out the most efficient way to launch a rocket is to use the Earth as a catapult to throw it into space. And that's why we tend to launch in a specific direction. And for those of you who come to the book club, which we're going to be talking about From the Earth to the Moon by Jules Verne, which was written over 100 years ago, the concept of using the Earth as a launch platform where you exploit the rotation of the Earth itself is in the book, and he got it right. So this is not new, but what it does mean is there's only certain places you can launch from, because you don't want your spent components to accidentally land on people. That's why we launch from Florida. Because on Florida, you can launch the right direction with the rotation of the Earth, and all of your spare parts fall into the ocean. Same reason why Russia positioned the Baikonur Cosmodrome where they put it, right? And in fact, one of the unfortunate countries was Israel, which actually doesn't have a good launch trajectory, and so they used the wrong orbit. So, if you're going to put up a space hotel, you have to put it on an orbital trajectory where it would go over your launch site. And that actually places some constraints on it. So if it were, say, an American space hotel, we would actually probably put it in a different orbit than one that the Russians would use, because our good orbits don't go over Baikonur Cosmodrome. So I think it depends, the answer to your question depends on which country are you talking to.
And I think if we are exploring concepts of like how this actually looks, what is the reality of this, the things that I've seen are these individual pods that are all around this orbital structure that can be used, multi-use. So residences, you have, similar to what we see on Earth, you have a desk, a bed, all these things, but then you do have to take into account, like we were talking about earlier, Rodrigo, like design of chairs and stuff, and like what is that gonna look like in microgravity? But then you have kind of getting towards that mental health piece and not going stir crazy from being in this enclosed environment, because of course, yeah, you won't be able to dine outdoors. There are windows that are sort of using the space environment and looking into Earth's atmosphere as a as sort of a I guess mitigation towards like that stir crazy nature. And then if you think about things around the greenhouse I was talking about earlier, using gardening also as a tool in this hotel to, since it closely mimics farming on Earth, that's a good way to have someone involved in the food supply chain, but also like a mental activity that is helpful to, you know, just maintain your psyche while you're there.
Thank you.
Yeah, I think the distance and the psychological effects of being away, and if your one option is a pod, perhaps there's a design of pods within pods to create you know, an enclosed exterior space. Because if you know, whoever is going to be able to be privileged enough to have these experiences from, you know, at least this decade, then there needs to be a very collective group of people with a think tank of what can you do in space and what is of value to do. Similar to how we like to travel. Do you have your pod, and then you have a larger pod that's sort of the patio, and then you have the pod inside the pod that's your dining, and then you're growing your food, or this is, you know, the space spa, you know. And so I think if there's, you know, anything is possible. It's just a matter of time and money. But it'll be interesting to see how that develops.
Yeah, there is actually a good reason, by the way, why we keep talking about pods and capsules. And that's because when you're in space, you need air, and you need it about 1 atmosphere. But space is very close to being 0 atmospheres. And so the place where you live is actually a pressure vessel. So my guess is a lot of people here have probably sprayed out whipped cream at some point. You have those little screw-in gas you know, widgets, right? And they're always capsule shaped. And they're roughly the same shape as a space capsule for the exact same reason, which is that cylinders and spheres are very efficient ways to contain pressure without hitting weak points. So you won't be seeing space hotels with sharp edges, for example. The architectural styles will be very circular.
I think we have time for 1 or 2 more questions.
This is so fascinating. Thank you so much for being here and talking about it. You know, I'm wondering how space travel can help deal with this planet's problems. You know, the lack of enough food and clean water and the extreme poverty that so many parts of this planet is experiencing. Can you guys comment on that?
Yeah, so one of the podcasts I was listening to earlier, I alluded to, was exploring things around the food supply. So we know that seeds, when they are in space, change their makeup and their behaviors. And by observing that and seeing what is produced in this harsh environment, we can bring them down to Earth for extreme temperatures like in the United Arab Emirates or in Africa, and using those extremely high temperatures to test if these seeds are going to grow in that environment. That will help us think about other ways to sustain food here on Earth. There's a lab that's based there called Star Stella Labs that is looking at this exact problem from the agriculture standpoint. So they've sent things like, they've grown dwarf tomatoes in space and then tested them to see if there's still the nutritional value there that a larger tomato would have. And then looking to test that plant against the deserts in the UAE, as I was saying, to see if we can expand the yield from that seed.
First of all, thank you so much for being here today. It's been very educational and outstanding. I'm curious, once everybody starts going to space and, you know, getting used to this whole system, is there a defense system set up in regards to keeping people safe? Because maybe I've watched too many Hollywood films. You never know, UFOs could be out there. Is there anything been taken in consideration in regards to that?
The laws and the treaties, and hopefully people will stay to the rules.
I think the biggest challenge aside from people. People are always a challenge. But the biggest challenge is that the space environment itself is very harsh. And it's full of debris. And that debris is going very fast. You have micrometeoroids just flying around. And if you have been tracking the news this week, you may have seen that there was a particulate impact on the C3 mirror on the James Webb Space Telescope, which just deployed 2 months ago. And because of the velocities that you find in space, that piece of dust, which was something you could barely even see with your eye, actually deformed this mirror. And so when you talk about pressure vessels, which are full of gas and humans, if you have holes that get punched in that vessel, you can have gas leaks. If those particulates hit your solar panels, you can lose electrical power. And so building vehicles that are robust with redundant systems is very important. You would have witnessed this on the crew demonstration vehicle 2 that Boeing just launched, where there is a thruster malfunction during an orbital raising procedure. Then there was a second thruster malfunction during that same orbital raising procedure, but the third thruster worked. And so redundancy upon redundancy and durability and testing the systems again and again is really important for launching humans.
I mean, like, if there's like a threat, like a UFO or something, that's kind of what I was kind of fearing of, because there's been issues and we've had sightings, and you just never know. If there anything set up with something like that.
Would you guys like to discuss the Fermi paradox?
I know this is out of the box, but you just never know. And like Air Force, they came up with or seen something on their radar a couple of years ago that is unidentifiable. But I'm just curious, when you do go to space, is there something set up in regards to if a situation like that comes up and you have this random spaceship starting to go attack you?
I'm going to answer that question. I'm going to ask you to join us on the third panel, where we'll be focusing a little bit more on UFOs.
Yes.
Okay, so that'll be in August. But I want to thank all the panelists for coming out today. My humanities advisor, Dr. Mark Knight. I want to thank ISMOA, California Humanities, all of you for coming out and supporting us. Make sure you follow ISMOA so you can stay up to date with all the panel discussions, book club, and the next panel discussion.